After being down for 3 years to undergo upgrades, the Large Hadron Collider will resume today, according to CERN experts. After they activated the Large Hadron Collider, an odd thing began to happen. Scientists at CERN were stunned and forced to re-evaluate what they knew when they saw something unexpected inside the mysterious particle realms when they turned on the massive collider. What, then, are the mysteries of the universe? Come along with us as we explore the uncharted territories of science, where novel discoveries are sparked by the unexpected. Since its establishment, the Large Hadron Collider at CERN has played a crucial role in important developments in particle physics. It has been at the vanguard of scientific investigation, expanding our understanding of the fundamental characteristics of matter in the cosmos. The Higgs boson was one of the LHC's most significant findings in 2012. One particle that lends mass to other particles is the Higgs boson. This mass-giving mechanism is caused by the Higgs field, whose existence was established by its discovery. This discovery marked a sea change in particle physics, and Peter Higgs and François Englert shared the 2013 Nobel Prize in Physics for their separate contributions to the Higgs mechanism. The LHC detector turned on all of its subsystems and started capturing high-energy collisions at the previously unheard-of energy of 13.6 TeV on July 5, 2022. The operators who had been working non-stop since the LHC's launch in April of last year made this accomplishment feasible. The LHC was scheduled to operate for nearly 4 years at this record energy, offering greater precision and discovery potential, following more than 3 years of maintenance and upgrading work. But when physicists turned on the LHC, they noticed something strange. Experts speculate that magnetic monopoles may be to blame. But are they real? Though theoretical concerns like the idea of quantized fields and the tightness of the U1 gauge group led to the idea of unification, magnetic monopoles have not been supported by actual evidence. Grand unified theories, GUTs, were developed as a result of physicists' exploration of this idea starting in 1974. These theories anticipated the existence of new super-heavy particles, the possible stability and decay of protons, and the existence of magnetic monopoles, as shown by Alexander Polyakov and Gerard T. Hooft in 1974. Although there isn't any hard proof for grand unification theory's applicability in our universe right now, it's still a possibility worth investigating. We look at the existence of illnesses that could interfere with or destroy the universe's ability to function. Overclosing the universe was recognized as a significant pathology when T. Hooft and Polyakov's monopoles were first postulated. By abruptly bringing a large number of hefty particles into the cosmos or by adding an excess of particles with non-zero masses, magnetic monopoles were believed to have the ability to resolve this issue. A possible remedy for this problem is inflation, which makes the world appear flat and gives all areas of our observable universe the same characteristics. This insight began to emerge in 1980 as interest in grand unified theories, early models of cosmic inflation, and T. Hooft and Polyakov's monopoles came together. A coil of wire specifically made to look for magnetic monopoles was used in a cryogenic experiment built by physicist Alvaro Cabrera in 1981. Cabrera used an 8-loop coil as the setup because he believed that a magnetic monopole would generate a particular signal by electric induction if it traveled through the coil. When Cabrera returned to the experiment the following day, February 14, 1982, he was shocked to see a single signal that closely matched the expected output of a magnetic monopole. Though the discovery prompted debate on inflation, the existence of magnetic monopoles, and whether it was an unprecedented experimental error, glitch, prank, or unexplained anomaly, it also generated a great deal of interest in the field. The detection of magnetic monopoles was attempted in a number of larger-scale studies, some of which included more loops in their coils and ran for longer periods of time. One of the primary theories regarding magnetic monopoles, which have been the focus of much study, is the potential for great unification. However, because there isn't any hard evidence, the truth about what happened in 1982 is still unknown. Because it can create magnetic monopoles at incredibly high energy scales, the Large Hadron Collider is a crucial instrument for researching the possible existence of magnetic monopoles. Observations of gravitational waves, which must be produced by inflation, also place restrictions on the maximum temperature attained during the hot Big Bang phase. Grand unification can only take place at energy scales higher than the previously indicated limit, hence if magnetic monopoles exist, they must have a very high rest mass, at least 10 to the power of 15 GeV. This is if grand unification is relevant to our universe. The exciting experimental evidence that suggested the possibility of magnetic monopoles appeared almost 40 years ago. The monopoles must have at least 70 times the mass of a proton, according to the researchers. This represents the first robust restriction on magnetic monopole mass. A hole in the Earth's magnetic field was found to have remained open for 14 hours after these tests. People started to think that anything from another world could pass through the door that CERN was opening. Experts believe there is no reason to be concerned, even though this hole appeared in the Earth's magnetic field. However, researchers concur that the hole let especially powerful solar winds in while it was open. Although it is rarely discussed outside of scientific classes, the Earth's magnetic field is essential to its defense. By keeping compass needles pointed north, it not only aids in navigation but also protects the ozone layer from solar winds that would otherwise destroy it. The importance of the magnetic field for life on Earth cannot be overstated, despite the fact that we don't talk about it often. Because solar winds can generate power spikes that can shut down entire cities and damage or even destroy satellites in space, NASA experts stress the need for additional research on these winds. However, whence did this vast field originate? It is formed by natural processes and contains co-rotating interaction regions, CERNs, which are sporadic occurrences from our hot neighbor, the Sun. These happen in the low and intermediate latitudes of the heliosphere when slow and fast streams of solar wind converge to form stunning sky tapestries. Imagine the heliosphere as a cosmic theater where spectacular performances occur. The very nature of co-rotating interaction regions pushes coronal mass ejections, CMEs, out of the theater created by the Sun's magnetic field and solar winds. Shock waves and compressed magnetic fields are produced by these CMEs, creating a symphony of space weather that produces stunning auroras in the sky. A long-lasting G1 geomagnetic storm was caused by an event that occurred early on the morning of July 7 in the field of magnetic seas. A coronal mass ejection shortly before the co-rotating interaction region revealed a complex story deep within the solar wind, according to the National Oceanic and Atmospheric Administration, NOAA. This split in the Earth's magnetic field raises the question of whether we should be concerned. According to experts, Earth's magnetic field fissures are not a cause for concern because they are transient and usually go away fast. New fissures, however, have revealed that they could remain open for several hours. However, NASA is interested in a mystery that has surfaced among the universe's myriad secrets. The Earth's magnetic field's waning intensity suggests that something might be amiss. Why it isn't as magnetic as the stars indicate is a mystery to scientists. From South America to Southwest Africa, a wide region has been affected by this anomaly. Known as the South Atlantic Anomaly, the mystery remains unsolved. Although NASA's satellites in this area cooperate effectively, our defenses against the Sun's charged particles deteriorate as the magnetic field does. Our lives are like a delicate dance between the skies and the vigilant guardians of space, and we are vulnerable. But there's nothing to worry about just yet. We have now reached the conclusion of this video. To be informed about all the discoveries we make, please leave your thoughts, theories, and experiences in the comments box below. Additionally, don't forget to subscribe and turn on the notification bell.